Well, there are many research topics to be covered on optical networks. However, I would like to put emphasis on flexibility and dynamics. So how we are able to provide real dynamism behavior on the optical core networks to really map the requirements and the needs that applications have. When I say applications, I say cloud computing. So cloud, we have many different types of applications. There are many demands, different demands. So data centers are growing and the needs they have too. So the issue is that so far how we expand the needs to data centers to the core networks. And it may mean that whenever we are moving data around, it's not going to be that useful to have fixed connections. So we have to provide here flexibility, dynamics, how we use flexi-grids, how we use elasticity on optical networks. So we have to be able to control these parameters in order to be sure that, as I said, the SLA requirements, the performance needs of the applications are really mapped down to the infrastructure. Because at the end, what we want is that infrastructures are application aware, which means that we are really customizing the service that we are delivering, because we are able to build infrastructures that really are adapted to the demand that applications have. And this is a big challenge. Whenever we are dealing with virtualizations, we have an analog domain, which is not a digital domain. So what is the impact of virtualizing the optical infrastructure? How we take care about the environments that we have. So there is a big challenge here, because as soon as we are able to abstract as soon as we are able to virtualize and abstract the infrastructure that we have underneath with all the optical technologies that we have, this is going to be an impact. An impact is the way that we interconnect data centers, or how we are moving data around. Also, there is the SDN and how software-defined networks may impact the optical technologies and optical communications. Here, what we need is to be able to provide a way on how we provide multi-layer, multi-protocol, multi-vendor provisioning. This is how we are able to provision or to orchestrate communications in an end-to-end approach when we are dealing with different heterogeneous infrastructures. So here is the point. What are the interfaces and how we are really to abstract all these optical domain technologies to be able to provide end-to-end and to deliver end-to-end services across different technologies. So basically the idea is that optical communications or optical networks has to be an enabler for clouds. So we are reaching the maximum capabilities, the network capabilities that data centers have. Now we have to see what's the added value that core and optical networks bring to the data center and to the cloud community itself, because it will change the paradigm and it will change also the way that applications behave nowadays. Whenever we want to deal with converged scenarios, which means to deal with multi-vendor, multi-layer, and multi-technology solutions, it's a key the word that or the outcomes that we can get from European projects. And this is a way, just because with these large projects you have the chance to involve vendors, to involve telecom operators, to involve researchers, and to have the whole value chain that is involved in a whole converged scenario. Since I personally think that the European projects, in the end, they are not only generating know-how, they are generating sometimes solutions that maybe are a step forward of what the community needs. However, they are marking a path defining what will be the evolution that we have now in Europe towards solving scenarios like the convergence. And this is very important, the way that IP, the big projects, are dealing with this topic.